Part 1, difficulty rating 2. The journey's going to take the journey's going quite well so far. There have been a few obstacles, but it has been relatively smooth sailing nonetheless. Neat. In today's meeting, the captain informs your team that the food supplies on the ships are slowly running out. The captain quickly assures you that it's not a problem. There are islands that have agreed to provide food supplies to support your mission. The captain hands you a map and a list of the Patron Islands coordinates relative to your current position. On the map, your current position is labeled 00. Each island's coordinates are written in the list. As the ocean tides are almost unpredictable, sailing in a straight line is quite tricky. So the captain suggests using Manhattan distances to represent the distance between islands. The Manhattan distance. Yes, I know what the Manhattan distance is. I'm good with that. First, the captain wants to know the difference between the distance to the furthest island and the distance to the closest island. All right. Let's get the input. I should write a little script to grab the input like I have for the for Advent of Code. So let's create a point. And are these XY, row column? What are they? Oh yeah, so it says X coordinate and Y coordinate right there. Very good. So we'll just do X. Looks like we can go negative, so let's use I64. Okay, so how do we want to strip the number here? We can split it with the comma space. And then we can say let x is equal to left 1 dot dot, parse I64 unwrap, and let y is equal to right 0 dot dot. I wish I could do -1 like you can do in Python. But we can say dot dot until right len -1 parse I64 unwrap, and then just becomes self xy, just like that. Inbound group, y is left 1, right 0. Oh, because yeah, I'm stripping out the brackets here. So open paren -16, I want to start on the negative there. And this is already starting at the negative and it goes to there. So it looks like, oh, we haven't called it yet. So let's do that. So we can say let points equals lines iter map line parse point unwrap collect into a vec. And then let's print out the points so that we can see that we've got all of them correctly parsed. And oh, because I'm running Clippy. Let's hit run. Here we go. So the first one is 218 minus 145, and the last one is 47,214. Perfect. So we're doing that correctly. Now we just need to get the Manhattan distance. Let's calculate. Let's add a little impl for that. Fn dist to origin, right? Because that's what we're looking for, is the distance from the ship's origin, and the one that's the furthest and the one that's the closest. So distance to the origin of self is going to give us an I64, and it's just the absolute value of self x plus absolute value of self y. That's not how you do it. Self x abs and self y abs. That's how you do it. Oh, and I actually have to use it. Println part 1. Oh, we need to find the closest and the furthest. Okay, so let's get all the distances. Let dists is equal to points, iter, map, point, comma, dist, point, dist to origin. Because we need to know what the point is, or no, we just need to know the difference. Okay, yeah. So we just need to collect up all the distances. All right, these are the dists. And then we just need to know the min and the max. So it's going to be dists max minus dists min. Right? Iter. The answer here is 649. Is it right? It's right. Yay. Okay. So git add source, git commit am problem 9, Patron Islands, part 1. What's part 2? Difficulty rating 2. The captain is now considering the closest island from your original position. He now wants to know the shortest Manhattan distance from that island to any of the other islands. Wait, what if there's a tie for the closest island from the original position? That's a good point. We'll just use the tied island with the smaller x coordinate. If there's still a tie between islands, then we'll choose the island with the smaller y coordinate. All right, that's been settled. You remind yourself that negative numbers are less than 0. I have to frequently remind myself of that fact. It's funny. What's the shortest Manhattan distance from the closest island from your original position to any of the other islands in the list? All right, so what we do is we find the one that's closest to 0, 0, and then we loop over all the islands and find the one that's closest to that. Okay. This is where we do need to keep track of the islands and their distances. Because I do need to know the point that we're dealing with. So do I want to? I'm hesitating because I'm thinking I want to put that in here, but that's going to mess up part 1. Right now, part 1 we can't just do dist iter max unwrap. But what we can do is say closest, because we'll need that for part 2, right? Is dists iter map. Oh no, we can say max by, min by, point dot 1, right? Unwrap, and then furthest is max by, right? Max by. Oh. Max by takes a comparator function. Isn't there like a there might be another one, dists iter, where I can just give it a value. Max by key. That's what I want, right? Returns the element that gives the maximum value for the specified function. Got it. So I can just say max by key and min by key. Oops. And then I can just say furthest dot 1 minus closest dot 1. Right, and it should still be 649. And it is. Okay. So, but now we have the island that's closest, right? We have a reference to that point. And now we want to find the closest to that. So we can write a new function called dist, right? Self other self I64, and this is self x minus other x abs plus self y minus other y abs. All right, and this will just give us the distance between two values. So we can now loop over all the points and see which one's closest to closest. So we can say let closest to closest is equal to points iter map point, and then we say point dist to closest dot 0, sorry, like that. And then we can say dot min by key. We don't care about the point itself, we only care about the dist, and that becomes dist. Like that, unwrap. And this should be the closest to the closest, and all we care about is that value. Okay, so println part 2 is equal to closest dot 1. We have to star that, and we got 0. Oh, of course we got 0 because we're including itself. So filter point is not equal to closest dot 0. And I probably have to deref one or both of those, right? That's a reference to a reference, and this is a reference. So I can do that, right? Oh, and we have to add equal and partial equal to the point struct. Okay, 46. Let's see if that's right. Yay. Why do we need furthest? For part 1, we need furthest to calculate that there. Because part 1 needs to know the distance from the furthest to the closest. Okay, let's commit that change. Problem 9, part 2. Let's see what part 3 is. It's also difficulty rating 3. There are over 50 patron islands to visit, so it'll definitely be too computationally demanding to find the shortest path between all the islands. One of your team members chimes in. They think they've got a suitable plan. First, we'll sail to the closest island from our current position. Then we'll sail to the closest island from there that we haven't visited. Oh, we'll repeat this process until we visit all the islands. And there's a tie. We'll do the X and Y coordinate. Oh, you know, we didn't do that for part 2, and we were supposed to. Oops. So we're going to visit all the islands in the order of the closest one, the next closest one that we haven't visited. Okay. And we have to do this XY coordinate business now, and I forgot to do that here. If 2 are equal. Which means we probably should update the min by to be a proper min by. I'm trying to think about the way I would like to do that. Because what we're going to do, here's my plan, is to put all the points into a hash set. Find the closest one, remove that from the hash set, and keep going. Where are we using points? And can it be used as a hash set everywhere? If I just change it to a hash set, will this all still just work? Oh, we have to make this hash. Yeah, but we still get the same answers. Oh, wait, that says 46. Was it 47 before? This is where I don't like the fact that, oh no, 46 is right. Okay. Or keep visited in hash set. Is point hashable? It is. It is now. Sorry. All right. So we still get the same answers because this doesn't matter about being a hash or a non-hash. And now what we can do is just pull the points out as we find them. We already know the closest one because we used that for part 1. And we know the distance to the closest. So let mut total equals closest dot 1. While points dot, let's say not points is empty. Then we're going to remove the point we just found. No, maybe we start 0, right? And we set our current point to be 0, 0. Oops. Oh, I forgot to close this. While points is not empty, then what we're going to do is we're going to add our current point or current distance. Can I do that? Well, let me do that. Total plus equals cur dot 1. And then we're going to set current. We're going to get our closest one, which is just going to be, we're going to recalculate our distances here. Equals points, iter, map, point. Maybe I extract this out, and this will be a point, comma, point dist to cur 0. Collect. This is sloppy, right? We probably should just loop over it directly instead, but this is what I'm doing for now. And then we can say, actually, we don't need to collect it, right? We can just say min by point. This is AB, right? And min by gives us a pair that we deal with. Yeah, it gives us a pair, not a tuple, just a pair of, okay. So we can say if, and these are point I64s, a dot 1 is equal to b dot 1. That means they're the same distance, and we're going by the smallest x coordinate. And if that fails, then we're going by the smallest y coordinate. So we can say if a dot 0 dot x is equal to b dot 0 dot x, then we're going to say a dot 0 dot y compared to b dot 0 dot y. Otherwise, if the x's are not equal, we'll say a dot 0 dot x is equal to, compared to that. Otherwise, the distances are not the same, so therefore a dot 1 dot compared to b dot 1. And I'm probably missing a couple of derefs in there. All right, this will give us the shortest distance to the next location. And then we want to remove it from points. So points remove a dist 0, cur equals dist. And I'm going to quit out of this because if I have an infinite loop here, I don't want to deal with that. Cannot borrow points as mutably because it's, oh, right, because dist is actually got a reference to that. So let dist equals dist.0.clone. That should remove the reference. Oh. Can I just clone the whole thing? Wait, I should have... we can do bacon clippy at least. When I do this, it should... Oh, it should be dist 0 clone. Got it. Comma, dist 1. This call doesn't do anything. Oh, because it doesn't implement clone. Okay. Well, we can do that. And now that. And now... Oh, shoot. Okay. We can change that, which means we have to deref it here, or ref it here. All right, we're getting closer. Now we just need to actually print out the value, which is going to be total. Oh, we can just deref it that way instead of calling clone. We can do copy since I declared it copyable. Okay. I'm going to quit and say cargo run. We got 6807 for the answer. Let's see if it's right. I clicked. Incorrect answer. Oh no. Wonder what I did wrong. Well, I guess we use our sample data, right? And pull that up here. G26, 114, and 6089. That seems... Is that what problem? No, 226 is correct. Yep. 114 is correct. And 1384. Okay. So what did I do wrong here? We started 0, 0. Is that what we're supposed to do? Right? So our aim position is still 0, 0. If you use your team member's algorithm, the order the islands visited will be these. So let's print out those and see what I got wrong. I can put this back into bacon. And let's just see which points we're visiting each time. Dist 4. Does it matter? I'll just say dist. So let's see if we get the order correct. 39, negative 132 is 171 distance, apparently. 16, 191, 74, 150. Okay, so I'm visiting in the correct order. It's just that I'm off. This is 1384, and I've added up to 1069. Oh, I'm not adding the last one in. What if I just put this here? Yeah, 1384. That was the bug. I got to add it up after I do it, and then if it's empty, we're done. All right, so let's switch this back. And it's 7609 now. Hey, okay. Git status, git commit -am. Part 3 for problem 9. Very good. All right, how much time do I have left? I have about a half hour.